Second video in a series that will review how to facilitate Unit 7, Day 24, Lesson 12C, completing the square visually. In the video previous to this, we talked about how to facilitate a conversation and execute live the contemplate then calculate routine. We will now talk about how to execute the connecting representations routine. The entire lesson has been built out on Desmos. So after finishing contemplate then calculate and students having an opportunity to reflect on their learning, you're going to jump to slide 11. And you're going to want to really use the pacing feature to keep students on pace with you. So I'm going to pace students right now on just slide 11. Okay, so what you'll start off doing first is going over the connecting representation strategy. What is it? It's a way to connect area models to quadratic expressions. Why are we doing this? We're thinking like mathematicians to use mathematical structure to connect two things that look different, okay? Giving them the context, especially if this is the first time you're introducing this routine. Again, using pacing. So during connecting representations, you are going to think, make connections, share and study those connections, create a representation, and then reflect on that learning. And we'll do this together as a class, and you'll have time to think independently throughout. Okay. And you might have students read this aloud instead of you reading it. So I'll model how I would start off this strategy. So in a moment, I'm going to show you a set of representations. I'm not going to have you move on to that slide. I'm just going to show it to you. And I just want you to think about and ask yourself, how are the area models similar or different? What are the chunks of these area models? So let's take a look. And I want you to just think for a moment. How are these similar and different? What are the chunks? Don't worry about this part right now. You're only focusing on these. Thinking about the chunks and how they're similar and different. Maybe you give about 30 seconds and then you open up that slide. Okay, take a moment to go ahead and jot your responses. Give students some time to write their answers. And then what you can do is you can do a number of things. You can use anonymize. You can use teacher mode and you can feature some student responses, or you can actually ask students to share out. Students can type into the chat. But we really just want to see some things like this. Oops, I don't want to look at the annotations just yet. So the models are similar because they both have a big square tile, little square tiles, and rectangle tiles. They're different by the rectangles are shaded in the first one, and there are different numbers of small squares. And then they said the chunks are big squares, rectangles, and little squares. And this person says the chunks are each part of the expression. So you want to feature this. You want to talk about it and give students a space to talk about it. Okay. They have time to do that. Now on the next slide, they're going to actually work to connect them. So I saw blank, so I connected blank. Blank matches blank because, and you want them to show their connections by annotating on the images using color. If you've never done this before, you're going to have a wide range of responses of what the annotations will look like, and that's okay. We want students to express their thinking through color and through writing on the images. So for this part, an option is to put students in breakout rooms and give them the chance to actually work on this together. You might put two people in a breakout room and have encourage them to share their annotation strategies. You might have them work independently and then allow them to work, kind of connect and debrief together. Or you might have them work together for the whole chunk of time. So you'll give them some time to do this. And the nice thing about Desmos is you can kind of track and say, okay, let me see how they're doing. Oh, they look like they have their annotations done and their explanation done. So we're looking at 15. And then this student maybe didn't have it done yet. Depending on when you see everyone is ready, you can bring everyone back together. And now we're going to have a conversation and we're going to share connections. So in this space, students are going to be able to say, we saw blank, so we connected blank, or blank matches blank because. And these are sentence starters that you can share with students. You can even try to keep them posted on the screen at the same time, or even just type them into the chat real quick so students have them to reference. And so there are a number of ways you could facilitate this discussion. Typically, you might look for a misconception. There aren't a lot of misconceptions that might arise here, but if you do see one and you want to feature it, that's great. What I did is I went ahead and snapshotted some students' work. And I asked students, so I snapshotted it. On the summary, you click the student's work, you click snapshot, and then it takes you here. And then I just sort of explain the connections they showed between the models and the expressions. And I'll actually put that down here as well. And it's anonymous. So what we could do is we could have, we could do one of two options that I can think of for this conversation. We could do one points and one speaks. You can have the student actually share their screen of their annotation to whoever you're featuring, and then they can point to different parts while their partner speaks aloud what the annotations were. So for example, their partner would say, I matched the x squared with the big box here, and the other student is pointing. This is tricky because logistically somebody has to share a screen. You could just run into a lot of problems. So another option that would work is you choose these student works to feature, and then you ask invite a student to explain the annotations that they see. Where do they see the connections? And so for example, a student might say, I see x squared. So they might say they connected A to 2 and C to 1. They showed that x squared matches the big box, and you could kind of point for them on your screens, like how I'm doing now. So they showed x squared represents the big square, and then they showed the 6x represents the blue. They didn't really show where the 11 represents, but they did circle these 11 boxes. So maybe they meant to put a green around there, and then they showed the 2 is right there. And then what about here? Okay, they showed again that the x squared is there. They showed the blue are those long rectangles, and then that was a negative, so that's why they're shaded in. And they showed the 7 was the 7 ones. And then they subtracted 2. They showed those extra 2 boxes that were subtracted. Interesting. Okay, so here's an example of kind of annotations that are clear. They could have added the green there, but they're decent annotations. Then we can have connecting representations here. These are much more detailed and a little bit neater, and we're going to show these next. So we're going to scaffold up, right, to the ones that are a little more detailed. Explain the connections. It doesn't as clearly show which one matched, so you're going to have to know that these matched. And they showed the unit squares in green for both of them. They showed the missing ones or the added ones in orange. X squared was in red. And then what did they do up here, right? This is what we want to talk about because this was what was different from the previous one. Why did they write x minus 3 up here? They're showing the dimensions of x minus 3. They showed that with the purple there, and they actually filled it in as x minus 3 by x minus 3. If somebody doesn't do this, you might ask students, well, where can we find the connection, the chunk of that expression on the image? This is x times x, that makes that x squared. If students have never worked with algebra tiles, this also might be a little bit trickier for them to really identify those dimensions. And so once students have the chance to show the connections, the goal of this is really to get students to think about what about that extra piece that's being subtracted by 2, and what about that extra piece those 2 that are being added? And how do we really see this as a square being completed and filled in? Or in this case, kind of a square with these 2 extra pieces. And we want to push students to make the connections between the representational image and the very abstract equation to kind of conceptually see and visualize what completing the square actually is. And these annotations are going to help students to do that. After you finish this conversation, the next slide, right, and again, remember how I'm keeping students pace this whole time just on the discussion slide, and you might even actually pace it where they're just on this slide because we don't want them working over here and correcting their annotations. We want them really listening and engaging in the discussion. Throughout the time that you're featuring annotations, you can have other students ask questions to repeat. What did you see they connected? What were their matches? How did they work? And they can use these sentence starters. Why did they work, I mean. The next part of the activity is for students to create a representation, and we'll talk a little bit about that in the next video. But in summary, connecting representations is a great strategy to help students make connections between abstract and concrete examples and representations.